Good morning. Today we're going to start looking at geometric series, which is just a geometric sequence that we are adding together. Our goal today is to define a geometric series and find their sums. All right, so again, a geometric series is the sum of the terms of a geometric sequence. And we have a formula to make that easy for us. To sum all of the terms in a geometric series, we take the first term times 1 minus r to the nth power, and we divide by 1 minus r. Now I do want you to put some extra parentheses in here. We definitely need parentheses around this whole denominator, and we also should put parentheses around this r and then have the n on the outside. So it's a sub 1 parenthesis 1 minus parentheses around the r, then to the nth power, close off that numerator, and then have the whole denominator in parentheses as well. That's going to ensure that you get the correct answer each time. So again, a sub 1 is our first term, r is that common ratio, and n is the number of terms in our sequence. So we want to use the formula to find the sums for these geometric series. The first ones here, we can just count how many terms there are. So in this example, we have 6 terms, so that tells me that n equals 6. Looking at to find our r value, we take the second term divided by the first. So it looks like we're just multiplying by 2. So now we know r, and we know our first term. So we can sum all 6 of those terms by taking our first term, and then we need parentheses, 1 minus our r value to the nth power. In this case, n is 6. We need to close off that whole numerator. And then in the denominator, we need 1 minus r. All right, so let's grab our calculators and look at how we type that in. So we had 3 parentheses, 1 minus parentheses around your r value, power, our number of terms was 6, close off that numerator, and then divide parentheses 1 minus r. So 1 minus 2, and then close that off again. So our total here would be 189. Okay, second example. Again, we're given a first term. To find our r value, we take the second term divided by the first term. So in this case, our r value is negative 1/2 or 0.5. And if we count up our terms, 1, 2, 3, 4, 5, n would be 5. So we want to sum all 5 of those numbers. We take our first term, parentheses, 1 minus our r value is in parentheses to the 5th power, our n value, and then we divide by 1 minus our r value. All right, so let's grab our calculators again. We need 20 parentheses 1 minus parentheses negative 0.5 power 5, close that numerator off, divide, and then parentheses 1 minus negative 0.5, and then close that off. We get a total of 13.75. Now those were fairly small sequences of numbers, so we could have just typed them in our calculator and added them up. But when we have sequences that are much longer, that's not very convenient. So our next one, we have a dot, 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 but this little n equals 9 at the end tells me that our sequence is only going up through that 9th term. Our r value is 30 divided by 6, or 5, so we're multiplying everything by 5. All right, so let's sum our 9 terms. We take our first term, which is a 6, 1 minus our r value to the nth power, in this case 9, and then denominator 1 minus the r value. All right, so let's type that in. We need, first term is 6, parentheses, 1 minus our r value was 5. We had 9 terms, and then we're dividing again by 1 minus r. And we have a total of 2,929,686. All right, for our next one, we have 12 terms that we are trying to add up. We know our first term, and then our R value, we take our second term divided by our first term, and we could reduce that. Dividing by 4, we get -3/2 or -1.5. All right, let's sum our 12 numbers. We take our first term, which is an 8, times 1 minus that R value, -1.5. And remember, that has to be in parentheses. Power would be 12. For the denominator, we need 1 minus our R value. All right, so once again, let's grab our calculator to type that in. We have an 8 for our first term. We need 1 minus our R value is -1.5. We had 12 terms, and we are dividing by 1 minus our R value. And we get -411.99. We'll just round. All right. So remember that if we're missing pieces of information that we need for our summation formula, we can simply use our explicit rule to find them. So our explicit rule for a geometric sequence is a sub n equals first term times r to the n minus 1 power. All right, so looking at this one, you'll notice this dot, dot, dot in the middle, and there's no n equals at the end of this expression. So we don't know how many terms we have. We can figure out our first term. We know that the first term is 3. We can figure out our r value just by taking the second term divided by the first term. So we know that we're just multiplying by 2. But we don't know our n value. So let's plug in what we do know. Our last term, our nth term, is 384. We started with a 3. We were doubling or timesing by 2 every time. We just don't know what that power was. All right? So to solve this, we're going to take 384 and divide by 3, which gets us 128. So you do have to divide that 3 out of there. You cannot multiply the 3 and 2 together and say that's just 6 to a power. We have to move that 3 out because it is not being raised to the power. All right, so now we have 128 equals 2 to the n minus 1. All right, so let's look at 2 to some powers. Actually, let's just solve this using a log. Let's take log base 2. Of 128 equals log base 2 of 2 to the n minus 1. Now we could use our power chart and look up 128 as well. So if you'd prefer not to use logs, we can do that. Looking at our power chart, to get to a 128, we had to take 2 to the 7th. So let's go ahead and just do that. 128 is 2 to the 7th power. That means 7 has to equal n minus 1, which means n would have to be an 8. All right, so we have 8 terms in our sequence. We want to sum all 8 of those numbers. We start with a 3. We are taking 1 minus our r value to the 8th power, and we're dividing by 1 minus r. All right, so we had 3 times 1 minus our r value of 2. We had 8 terms, and we're dividing by 1 minus 2. So our total should be 765. All right, remember in summation form, to find the first term, we really just plug in the very lower limit here. Whatever they're telling us is our bottom number here. So in this case, it says n equals 1. So we're going to just plug a 1 in. So 4 times 1/2 to the first power. 1/2 to the first power is still a half. 4 times a half would be 2. So our first number is a 2. And then our R value is just that 1/2. It's the piece that's being raised to the power. Okay? And then we need to figure out what our N, total number of terms. Well, if we're starting with a 1 and we're stopping with a 5, just counting 1 through 5, that's 5 numbers. So we want to find the sum of our 5 numbers. Our first term was 2. We need 1 minus our R value of 0.5 to the nth power divided by 1 minus 0.5. All right. You can pause the video. Go ahead and type that in your calculator. You should be getting 3.875 for an answer. All right, for the next one, just use a little caution here because notice that we are starting with an n value of 0. So to find that very first number that we're supposed to use in our formula, we actually have to plug a 0 in for n. So 5 times -2 to the 0 minus 1. Our first term in our list, 5 times -2 to the -1 power, which means we're flipping that over. It's really -1/2. -1/2 times 5 would be -2.5. That's the first number in my list. Okay. My n value, remember we're counting from 0 up to 9, which is actually 10 numbers. So there's 10 numbers in my list. And again, my R value is just the piece that's being raised to the power, which is that -2. All right, so let's sum these up. We are summing 10 numbers. Our first term was -2.5. We need 1 minus our R value to the 10th power, and then 1 minus the R value on the bottom. All right, let's grab a calculator. We have -2.5 times 1 minus our R value, -2 power 10, divided by 1 minus -2. All right, we get 852.5. All right, our last question deals with a story, a famous story, that involves a soldier who rescues his king in battle. The king grants him any prize within reason from the riches of the kingdom. The soldier asks for a chessboard with a single kernel of wheat on the first square, 2 kernels on the second, then 4, then 8, and so on. So our sequence, we have 1 on the first square, then 2, then 4, then 8, etc. The king decides that the request is reasonable. Now, on a chessboard, it's an 8 by 8 grid, so our n value, there would be 64 squares in that. According to the story, how many total kernels of wheat did the soldier request? So we know that our first term is a 1. We know that n is 64. And looking at our pattern, we're just doubling it each time. So our R value is 2. So let's look at the sum of all 64 of those numbers. First term is 1. We have 1 minus 2 to the 64th power over 1 minus 2. All right, let's grab our calculator. The first one we don't really even need to type in because multiplying by 1 doesn't do anything. 1 minus 2 to the 64th power divided by 1 minus 2. So we end up with a very, very large number. This e to the 19 here at the end means our decimal is really 19 spaces to the right. So we end up with 1.84 times 10 to the 19th power. That's a lot of kernels of wheat. It says the rest of the story. A bushel of wheat contains about 1 million kernels. The total U.S. output of wheat in a recent year was just over 2.1 billion bushels. How many years of production at that level would it take the United States to produce enough wheat to satisfy the soldier's request? All right, so we have 1.84 times 10 to the 19th. Let's figure out how many billions that is. Sorry, how many millions that is. All right, dividing that, this is really just 10 to the 6th power. So we end up with 1.84 times 10 to the 13th. That's how many, since there's a million kernels in a bushel, this is how many bushels we have. Okay? And then it says that in a year they can make 2.1 billion bushels. So we can take 1.84 times 10 to the 13th, divide it by 2.1 times 10 to the 9th would get us a billion. A billion has 9 zeros in it. So this is going to take, if we divide this out, it's going to take 8,784.16 years to create that much wheat. So his reasonable request was really not very reasonable, and the king should not have granted it. All right, you guys are going to work on geometric series using 9.5a worksheet.